Okay, let's get started. I'm pretty confident that this weekend I'm going to give you a take-home quiz. There's going to be a lot of properties of exponents and stuff on it. So we just need to make sure we're good with them. So here's an example of properties of exponents. So we have negative 4x, y to the negative 3, z squared, all over 4x, y cubed, z to the negative 5th. So looking at this, guys, we're going to go through and piece by piece simplify something like this. Now, we would sing our properties of exponents, but remember these few things. With properties of exponents, it only works when dealing with exponents. So when you sing the song, it's not going to be true for numbers. Yeah, that's true. It's pretty bad. So it's not going to be true for numbers. Just remember that, okay? When you multiply, you. When you divide, then you. Right? And you subtract the bottom or the top? Top from the bottom. Good, Jesse. Raise the powers to a power and you multiply the powers. Yeah, good. Very good. Okay, so now I just said it doesn't work with numbers. You just divide your numbers. What's 4 divided by 4? 1. What's negative 4 divided by 4? Negative 1. So those divide out and become negative 1. Questions on that? Now right here we have the same base, x and x. Well, first of all, let's just quickly look at this. What's x divided by x?
X.
Is it x?
1.
It's 1. Good. Very good. It goes away and becomes a 1. And then now over here, we have y to the negative 3 divided by y to the third. Don't just look at those and say they divide out, because they don't. We have to take the top from the bottom. So I'm going to draw my line. So far we have negative 1 and 1. And then we do y to the negative 3. Negative 3 is on top. Subtract the bottom. So what is the bottom? Subtract 3. Now careful, guys. What's negative 3? What's negative 3 minus 3 more? Negative 6. Okay, do we have questions on that part? Okay. And then let's go to our z's. We do z to the 2. And notice how I do it on top. That's another little thing to remember. I'm doing it on top. So 2 minus what? Negative 5. So 2 minus negative 5. What happens when you subtract the negative? Becomes positive. So we'll be adding. Very good. So what's 2 plus 5? Z to the 7th. Now from here, you'll flip negative exponents, not negative numbers. Negative numbers are good. So we only flip negative exponents. So with this one, you tell me, what am I going to flip? Good. The y to the negative 6. I flip the whole thing down to the bottom, and then it doesn't become positive. That was the whole point of doing it. So on top, what's negative 1 times 1? So we have negative 1, and then what's left on top still? Z to the 7th, and on bottom we have y to the 6th. Now on an ACT, they would go one step further. On my test, if it was multiple choice, and I'm going to make it a goal on the next test to do a few multiple choice for you, I would go a step further. Because negative 1 times z to the 7th is just negative z to the 7th, right? That's the same thing. It goes without being said that the 1's there. So this would be the most correct answer. I would have accepted this one on a test, though, if it wasn't multiple choice. Questions on that? Are we getting more comfortable with properties of exponents, the stuff we should have learned last year? Okay, good. That's good. That's what I like to hear. All right, let's get to the new stuff. Now, all my examples today are going to be from your worksheet, so that's good because many of you like to move on. But just make sure, remember, we're making it a goal to not move on without unless you're supposed to. Because remember that a lot of you, yesterday was a good example, we didn't get to finish the lesson, and you had questions, right? So today, make it a goal to not move on unless you're supposed to, and then you will be good to go with the worksheet. So yesterday we were simplifying roots and radicals. Today we're going to be multiplying and dividing radicals. So let's start out. When multiplying and dividing radicals, you must have the same root. So really, that's the only rule. For multiplying and dividing, the only rule is you have to have the same root. So you can't take the square root and times it to a cube root. So you can't take a square root and divide it by a cube root. It has to be the same root. That's the first and really only rule. Questions on that? Makes sense. So if you saw something like this, the square root of 5 times the cube root of 5, that is the furthest we can go. We can't put them together. Does that make sense, everybody? Okay. Awesome. All right, so when multiplying or dividing roots, guys, what you're going to do is you're going to take your roots that are separated, you're going to put them together, and then simplify. We know how to simplify. It's what we learned yesterday. So you're going to put the roots together, put them under one house, and then go through and simplify it. So let's do number 1. Let's start out with just numbers. So we have the square root of 4 times the square root of 5. Can we multiply these? Yes, they're both square roots. So we're going to rewrite this as the square root. Now take my suggestion. Just rewrite it as 4 times 25 under the same root. If you actually multiply that together, that's fine. But then we're going to end up breaking it back down anyways, right? So why not just leave it split apart and make it easier on yourself? So now understand, yes, they're multiplied together, but now I'm just going to break them down individually. 4 breaks down into 2 times 2, very good. 25 breaks down into 5 times 5. And all this stuff is being multiplied. That's one thing to understand. Now we're pulling out groups of how large? 2. So there's 2 2s right there that we can pull out. There's 2 5s that we can pull out right there. Now when we pull them out, remember, you're only pulling out one of those, accounting for the 2 of them. Because really what you're doing, guys, is the square root of 4, which is 2. So you're just pulling out a 2 for those 2 2s. So just remember that. And then we're pulling out a 5 for those 2 5s. And was there anything left under the house? No, so it's gone. So our answer will be 2 times 5, which is 10. Not too bad. Yeah.
So like factoring and stuff, when we get there, you know the square root of 4 is 2, and the square root of 5.
Yep, that's a great way of doing it too. So you could do it like that. You could say, what's the square root of 4? It's 2. And then what's the square root of 25? It's 5. So yes, you could do it like that. That's almost easier. The only reason I'm showing you like this is because when we get 2 variables, it'll be easier to put them under the same house. So yeah, very good, Dylan. You were able to see that, yes, you could just do the square root of 4. It's 2. The square root of 25 is 5. So now you can just multiply them together. Now, once again, it's not always going to pull out evenly like that, so we just have to be careful, but that's absolutely fine. Yeah, great. Very good point. Okay, we're going to do another one. Number 4. So number 4, the cube root of 45 times the cube root of 75. Now, yeah, that paper is really squishy. I would really suggest, especially because we're going to get to some really lengthy problems, to do it on your separate sheet of paper. There's just more room for error, and I can't really help you when your writing's all squished. Yeah. Yeah, use the back. Good idea. Yeah, use the back. Very good point. All right, so doing number 4, we have the cube root of 45 times the cube root of 75. First of all, can we multiply these? Yes, and you really should check that first, because really, it would be a shame to miss this one on the test because you multiply them when you can't. So we'll rewrite this as the cube root of 45 times 75. We could multiply those things together. We'll end up breaking it down anyway, so why not just leave it like this? 45, give me some factors, any factors. What is it? 8 and 5. 9 and 5. Yeah, good. Thank you. 75. 3 times 25. Let's go with that one. All right, let's look down here. Can we break down any more of these? 9 breaks down into 3 times 3. 25 breaks down into 5 times 5. Now from here, be careful. Are we pulling out groups of 2, 3, 4, what? Groups of 3. We know that because it's a cube root. So if there's 3 of them, it can leave the house. Otherwise, it's got to stay. So there's 3 3s right there. So we'll pull out a 3 for those 3 3s. And then right here, there's 3 5s. Now make sure not to double dip. Did we pull everything out?
Yeah.
Yes. So we pulled out a 5 for those 3 5s. We pulled everything out of the house, nothing left. 3 times 5 is 15. Very good. Okay. Any questions? All right. Do 1 through 6. Ready, set, go. Let's go ahead and do expressions instead of just numbers, okay? Now remember that yesterday we learned how to break down and simplify these expressions, and then we learned the even, odd rule. Does everybody remember that? Even, odd. So I want you to think for a second to yourself, what was the even, odd rule? Don't answer it out loud. Okay? Even, odd rule. Okay, ready, set, go. Tell your group what the even, odd rule was. All right, group 7. Group 7, yep. Tell me, what did you come up with as an answer for even, odd?
Even odd rule is one where the even number.
Just a second. Everybody listen real quick. What was the even, odd rule?
Like the even number, if it's even and even inside, and then it comes out to be an odd exponent.
Then what?
Then you
Good.
put the absolute value.
Perfect. So if we have an even root and an even power underneath, and then we simplify it down, and we have an odd power as an answer, we'll add the absolute value signs to take care of any unnecessary negatives. That would give us a problem. All right, so now today, the nice thing is, guys, you don't even have to know the even, odd rule, because today, by the directions, it says simplify and assume all variables are positive. So since we're assuming all the variables are positive, we don't have to put the absolute value sign because we're only dealing with positive numbers. Now on the test, on the take-home test, pay attention because now we know. If it doesn't say that, if it just says simplify, if the even, odd rule applies, you must put absolute values. But today, we're not going to have to deal with that because we're assuming all the variables are positive. All right, let's simplify this one. We were doing this yesterday. Let's just break it up. What is the square root of 36? Let's not make it harder than it is. It's 6. Now remember we learned a trick yesterday. We don't want to have to rewrite this as x times x times x and then pull out groups of 2. We want to be able to go ahead and do it using division. So we'll go 3 divided by 2, which is, this is kind of different because yesterday we had all roots come out evenly. So everybody watch. What's 3 divided by 2? 1 point what? 1.5. So it goes into it once evenly, right? So we can pull out 1. So we'll pull out an x to the first. It goes into it once. And then we need to know our remainder. Now you can't use the 0.5. Just do it like this. 2 times 1 is 2. How many more do we need to get back to 3? 1. So our remainder is 1. So that's what's remaining in the house. So now you'll put your roots. Remaining was x to the first. Now you could have done it this way. You could have circled groups of 2. You pull out an x for those 2 x's, and then left underneath was x. Does everybody see how I got the same answer that we would have got if we would have done it the long way? Depends on who you're asking on which way is easier. But there just will be problems today that will be quicker to do it this way. So that's why I was going over that. Yeah. No, it's not. Oh, yeah, good question. So we do 3 divided by 2 because it's a square root. So we take our 3 and divide by 2. No, that's a great question. Yeah. Any others? Thank you for asking. All right, let's do another one. Number 15. Okay, number 15. We have the 4th root of 625 u to the 5th b to the 8th. Now, take my suggestion. The first thing I try is to see if it's a whole. I don't want to have to break it down if possible, but we'll see. We might have to. I'll take on my calculator the 4th root of 625 and see if it comes out evenly, because if it does, then you're done. But if it's a decimal, you have to go back and break it down. But why break it down if you don't need to? So take the 4th root of 625, and what do you get? 5. So we know we pulled out everything, and we got a 5 out of the 625. Once again, though, you all understand that if it's a decimal, you have to go back and break it down and pull out groups of, how big are our groups in this one? 4. Very good. All right, so we took care of 625. Questions on 625? Okay, let's do this next part, but let's be careful. Now, we learned something new today. Today, we're going to have remainders underneath, stuff remaining under the root. So let's go through it slow. So we're going to do 5 divided by 4. 5 divided by 4, because we're dealing with our u. Let's simplify our u's. Let's pull out what we can. 1.2, some 2.5 you said. Okay, all right, so how many times did it go into it evenly? 1. So it went into it once, so we'll pull out a u to the first, but then there's something remaining. Now ignore the 0.25. Ignore the 0.25. It went into it once, so 4 times 1 is 4. How many to get back to 5? 1. So our remainder was 1. So then that's what's remaining under the house. So we're still going to have our 4th root, and remaining is a u to the first. Did that make somewhat of sense? It'll get better with practice. And then now let's do b to the 8. So we're just focus on 8. Take 8. How does 8 break into groups of 4? 2. Very good. So does it do it evenly?
Yes.
Yes. So we're pulling out a b squared. Nothing remains under the house. So this would be our final answer. Now once again, keep in mind, we're not going to write the first powers. So 5ub squared. Fourth root. Common errors, people forget to write the fourth root of u. I'm not going to write in my first powers because we're more advanced than that now that we're in secondary period. All right. Do you have questions on that one? What if I would have had remainder 2? What would have been left underneath? A u squared. Good. Yeah. All right. Do 7 through 15. Okay, so just remember one thing though. Let's say you got really desperate on the test and you couldn't remember how to divide things and what was remaining. Could you go back to the caveman style and draw out 10 Z's if you had to? Yes. So, I mean, keep in mind, you can always, you can do that. I'm just teaching you other methods that are more effective. But I mean, it never hurts to say, well, I don't remember that, so I'm going to write out 4 Z's and circle groups of 3. You know what I mean? Okay? So remember that. All right, so now let's do number 21 together. So now we're going to be multiplying and simplifying. So we practiced multiplying radicals. Now we practice simplifying. Let's put those two things together. We're going to multiply together and then simplify. Couple things to remember. You multiply them if they're the same root. Now if there's stuff already on the outside, you're going to multiply those things together as well. So look at number 21. 9 times the square root of 2 times 3 times the square root of y. Now notice, I could have said it like this. 9 square roots of 2 times 3 square roots of y. Nevertheless, though, it still means the same thing. We could just think of this as 9 times the square root of 2 times 3 times the square root of y. And then remember with multiplication, you can reorder it in any order. So I'm just going to do 9 times 3 because it's on the outside of the root. So what is that? 27. Okay, so we have a 27 on the outside. I multiplied 9 to 3. Now since these are both under the house, we can multiply them together. They're under the same house. So we'll have the square root of 2 times y, right? Which is just 2y. Now let's look and see, can we pull out anything underneath the house? If we did, we would just multiply it to our 27. Can 2 come out? Can y come out? No, so this would be our final answer. Now notice again in the instructions, it says assume all variables are positive. I probably should have erased that off of my worksheet because it would be good for you guys to practice, because on the test, if it doesn't say that, you have to put those absolute value signs if needed. Okay, all right. Questions on 21? Okay, let's do 23, a little bit more advanced here. So number 23, we have the cube root of negative 9x squared, y to the 4th, times the cube root of 12x5. Can we multiply these things? Yes, they're both cube roots. So I'm going to rewrite these under the same root, and I'm going to put all my bases that are alike by each other. So I have the cube root of negative 9. I'm going to put the number by it, negative 9 times 12. And then I'm going to have my x squared and my x, so times x. I'm just reordering this. Then I have y to the 4th times y. Now it's a matter of choice, preference, whatever, on how you continue from here. You can either just break down things from here and circle groups. I'm not going to do it that way. I'm going to do it the way where it's going to be different. It's going to be, I think it's easier. But once again, from here you could break those down and then circle groups of 3 if you had to. So I am going to break down 9 and 12 though, because really with numbers you have to. So let's ignore the negative. We just know our final answer is going to be what? Negative. So we'll remember that later. 9 breaks down into 3 times 3, right? 12 breaks down into 3 times 4, and 4 breaks down into 2 times 2. Okay, I'll let you catch up from there if you need to. Okay, so I'm breaking down my numbers. Now, how big of groups am I pulling out?
3.
Groups of 3. So we have 3 3s right there that can come out. So we have a 3 on the outside so far. Now I'm going to leave myself plenty of room. There might be more things to pull out. Can I pull out the 2's? They must stay. So I'm going to write my root, giving myself room to finish out my answer if need be, and then I'm going to put my 2's back under. Now that's 2 times 2 left underneath, right? Which is 4. Okay, questions up to there. Okay. Now from here, we had x squared times x. Well, that's x to the 3rd, right? And then I have y to the 4th times y, which is y to the 5th. Now we're pulling out groups of 3. So now I'm going to use the trick. I'm going to focus on x. How can we split 3 into groups of 3? So you'll do 3 divided by 3, which is 1. It goes into it once evenly. So we're pulling out an x to the 1st. Now I'm going to do this part. So 5 divided by 3, I'm going to look at my y's. 5 divided by 3 goes into it once. So we're pulling out a y to the 1st as well. Now this time our remainder is not 1. We got to think about it. 3 times 1 is 3. How many is remaining to get back up to 5? 2. So left underneath is a y squared. Now we'll write our answers pretty style, and we'll do at 3, x to the 1st is just x, y to the 1st is just y, not forgetting to write the cube root of 4y squared. And then I forgot the negative. Thank you for fixing that before it was too late. So our final answer is negative. Thank you so much. All right. Do you feel pretty comfortable with those, or do I need to do another one? So thumbs up if we're good, you're ready to practice. Okay, awesome. Okay. 16 through 24, and then we'll move on. All right, so now we're going to be dividing. So now you know how to multiply roots. Now we're going to divide the same roots. So our first thing we're going to do is we're going to put it under one root, simplify what's under the root. Now this first step makes it way easier on us. And then second, we'll split it back up and simplify the root. So we'll simplify the top, simplify the bottom. And then if on bottom simplifies and it still has a root, we've got to rationalize the denominator. And then we have to simplify even further. So you've just got to be really careful with these. So first things first, put under one root, simplify what's under the root so that we can have smaller things. And then we'll split it back up and simplify the roots individually, one on top, simplify the one on bottom. And then if necessary, we'll rationalize the denominator. All right. Couple more seconds and then we'll do some examples from the worksheet. Okay, we're going to do problem number 26 together. All right. So we have the square root of 63, xy cubed, divided by the square root of 7y. So let's rewrite this under one root, simplify it, and then we'll split it back up. Now, we could just start from here and rationalize the denominator, but there's a lot bigger numbers if you do that. So I'm going to rewrite this as the square root of 63 xy cubed over 7y. I just put it under one root, and it was a square root, yeah. And now you'll go ahead and simplify the numbers using properties of exponents. With our exponents, we'll simplify using properties, and then we'll continue to simplify. So tell me what's 63 divided by, so I'm rewriting it, what's 63 divided by 7? 9. So 9's on top, right? 9's on top, right? 63 divided by 7 is 9. And then we have an x, no other x's, right? So x needs to stay on top. And then we have y to the 3rd on top divided by y. So we're going to have what? Y squared on top. 3 minus 1 is 2, so we have y squared. So our bottom's gone. So now all we have is the square root of 9x y squared. The bottom's gone. So that's kind of nice. Do you see how much easier that was than rationalizing the denominator from the beginning and then going through it? It didn't need to be because there's no denominator anymore. All right, so what is the square root of 9? 3, so we'll pull out a 3. Can we pull out x? No, so it's going to stay under the house. Can we pull out y squared?
Yes.
2 divided by 2 is 1, so we'll pull out a y squared. No remainders. Well, I mean a y to the 1st No remainders. There's our answer. It's not too bad, right? Yes. And we wouldn't leave the 1. Yeah, good question. Thank you for asking that, Cole. All right, one more. Number 29. Let's do that. So we have the cube root of 4x squared divided by the cube root of x. So it's going to be easier on yourself if you bring them together. So I'm going to say the cube root of 4x squared over x and simplify it. So then we still have the cube root of 4 doesn't go down with anything, so we still have a 4 on top. And then x squared divided by x is x. So our denominator is gone again. So all we have is the cube root of 4x. And then from here, we'll simplify it. 4 breaks down into 2 and 2. X is x. Can we pull anything out? No. So our final answer would be the cube root of 4x. Bring them together, simplify it, and then simplify the root. That's the steps. Okay, do you feel comfortable to go? Okay, awesome. Because if you want, I can do, oh wait, let's just move on. We don't have, yeah, let's just move on because this is the same thing, but different. So look with me, sorry. And then I'll let you work the rest of the time. So rationalizing the denominator. We can do this a couple different ways. We can either bring it together and simplify it and then rationalize the denominator. Should we do it that way? Do you want to bring it together and simplify it first? Okay. Okay, that's fine. So we have the cube root. Now pay attention here. This is where it gets hard. This is where it's going to get hard. So we have the cube root of 7xy squared on top. On bottom we have 4x squared, right? Okay. So if we simplify this, we have the cube root of 7 on top, right? And then x over x squared. We still have our 4 on bottom. X over x squared. You do 1. Oh, it's almost harder. This one's almost harder of bringing it together. So we do 1 minus 2, which is -1. So we flip it, right? So we have an x to the first on bottom, right? And then our y's. Any other y's? No, so we have y squared. So then from here, we would split it up. We have the cube root of 7y squared on top, and on bottom we have the cube root of 4x. Okay, so now we have rationalized denominators in the past with square roots. We needed 2 of them, right? We needed 2. But with cube roots, how many do you think we need? 3. So this one's going to be a little bit trickier. All right, so this is what we'll do. We'll rewrite this bottom part in its factors. So I'm going to rewrite this instead as the cube root of 7y squared on top, and on bottom I'm going to rewrite it as the cube root of 4 is 2 times 2, right? So 2 times 2 times x. Does everybody see how I rewrote the bottom? This is the trickiest part. Now we need to rationalize the denominator. So we've got to get rid of this root. Well, there would have to be 3 2's in order for that to cancel out, because then we would have 2 cubed, right? We have 3 2's. So we're going to multiply the bottom by the cube root of 2. Now that would give us 1, 2, 3 2's, right? So I only had to do 1, 2. And then how many x's do we have? 1. How many do we need? 3. So how many more do I need to multiply by? 2 of them? Yep. So if you do that to the bottom, you've got to do it to the top. You can't just do it to the bottom. So I'll multiply the top also by 2 times x times x. And now we'll go ahead and multiply the top part together. So we have the cube root of 7 times 2. Well, if we can break it down, we'll pull things out if there's groups of 3. 7 and 2, are we going to pull anything out? No, so we'll leave it underneath. So what is 7 times 2? 14. Now look at our y's. We have a y squared, any other y's? So there's not going to be 3 that pull out. So we still have a y squared left underneath. And then we have an x and an x. Can we pull out either of those? No, so we'll still have an x squared left underneath. So everybody see how I simplify the top? Now the bottom, what we had down here was the cube root of, because we fixed it, we had 2 cubed, x cubed, right? There was 3 2's, 3 x's. True? So then what happens? Our root cancels out with our powers because they're the same roots. So left underneath is 2x. This would be our final answer. Kind of a process, right?
Yeah.
Yeah. So this one actually would have been quicker to not split it up and then to simplify. If we would have just rationalized the denominator from the bottom, that would have been way quicker. Okay, does everybody see though how I fixed it? It was kind of tricky. We're going to do another one. These two right here. We chose to multiply the bottom and the top by a fancy one, but we're picking the one to help us fix the denominator. So we picked 2 because there was 2 2's already, so that there would be 3 2's. There was only one x though, so we needed 2 more to make it 3, so we multiplied by 2 x's. Okay. Let's do number 39 together. So we have the cube root of x squared over 3y. So let's split this up. Let's just split it up. So we have the cube root of x squared on top, and on bottom we have the cube root of 3y. Now once again, this is a cube root, so we need 3 of them. So now let's go ahead and say, okay, let's fix this. Let's rationalize the denominator. We need 3 3's. So how many more are we going to put under? 2 of them. 3 times 3, so that there's 3 total. We have 1 y in this one, so how many more y's do we need to get 3? 2. So y and y. Now if you do that to the bottom, you've got to do it to the top. Now that's just a fancy one we're multiplying by. So we'll multiply everything underneath on the top together. So we have the cube root of 3 times 3 is 9. We have an x squared. We have a y squared. Can we pull any of that stuff out? No. And on bottom, we have the cube root of 3 cubed, which is and then we have on bottom 3y, so the cube root of y cubed is y, right? Okay, those ones are trickier. Do you need to see another example, or are you going to be okay? Yeah, let's do another one. This one. We have the cube root of 3x over 2y squared. This is a good one to do. So we'll split it up and rewrite it as the cube root of 3x over the cube root of 2y squared. Let's write it as y times y, so that we can see how many we have. Now we have to rationalize the denominator. Once again, this is a cube root, so we need 3 of them. So let's multiply by the cube root of, we only have 1 2, and we need 3, so how many more? 2 times 2, so we have 3 of them. And then y times y, we need 3, so we need 1 more. If you do that to the bottom though, you've got to do that exact thing to the top. So then on top we have the cube root of 2 times 2 times 3. Is there 3 of them that we can pull out? Those aren't the same, right? So they're going to stay. 2 times 2 is 4. 4 times 3, 12. Then we have an x and a y. Then on bottom, we have the cube root of 2 cubed, right? So those cancel out, leaving us with the 2 on bottom. And then we have the cube root of y cubed, which is just y. Now notice this is under the house and this isn't, so we can't divide them. But if we did end up pulling something out, we'd have to look and see if they simplify. Okay. You feel okay? If it's a square root, we don't need 3 of them, we only need 2 of them, right? Okay, awesome. So do problems, the rest of the worksheet. So with the 4th root, I won't go through this one. How many 9s do we need? 4. There's 1 of them. Oh, but let's rewrite. Let's rewrite 9 as 3 times 3, right? That would be way easier. So how many 3's am I going to multiply by? 2 of them, and then how many more x's? 3. Good. Yeah. Okay, good. All right, so finish the worksheet.